Welcome to the problem solving lesson, and again we'll start with a quick warm-up before we start the problem solving lesson, which is the last topic in sets and Venn diagrams. Right, so let the universal set U be defined as the set of positive integers less than 10. So when you think of less than 10, you've got to think of the fact that it doesn't include 10. So let's just write out the universal set, for example, positive integers, so positive whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does it include 10? No, it doesn't, because the word's less than 10. So it's worth having kind of the universal set written out in this question. The subsets A and B are defined as A is the integers that are multiples of 3. So of course they have to be part of the universal set. So if you look in the universal set above in green, the only multiples of 3 are 3, 6, and 9. So list the elements of A, you've already got the answers. 3, 6, and 9. Let's close the curly brackets. List the elements of B. B is integers that are factors of 30. So numbers that divide evenly into the number 30. In this case, the factors will be 1, of course, 2, 3, 5, 6. Of course, there are other factors of 30, like 10, 15, and 30 itself. But these all have to be numbers less than 10, because the universal set is the one in green above. So from these, we have to pick from the green universal set. So that's why we can't include 10, 15, or 30. Because even though they're factors of 30, they're not positive integers less than 10. Then we're asked to place the elements of A and B in the appropriate region in the Venn diagram below. So the Venn diagram below, try to think what would go in the center. So the intersect would include, as you can see, a 3, because there's a 3 in both, and a 6. So the center needs to include 3 and 6. So let's work from the center out. And U has already been listed here, so we'll just leave the U there. Look at that. Then try to think what else is in A that's not in this intersect, and it's the number 9. So A needs to include the number 9. What's in B that's not part of the intersect? You can see it's 1, 2, and 5. So 1, 2, and 5 has to go in the only B section. And then you might by accident think you're finished, but you're not, because you don't have all the integers from 1 to 9 listed. So let's see, we've got 1, 2, 3, we're missing 4, 5, 6, we're missing 7, and 8. So just check you've got all the integers, positive integers from 1 to 9. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So you know you're good. And that's the end of the warm-up. Let's move on to the lesson part. Problem solving. So in problem solving, it's just more difficult versions of Venn diagram solving, just slightly more difficult. So you're still using the same skills as you were using in the previous lessons. They're just applying them to slightly more difficult real-world problems. So this example, in a class of 42 girls, 25 play soccer and 27 play rugby. So if 3 play neither sport, how many play both sports? So it's a 2-circle Venn diagram, and there's going to be an overlap because of the word both sports has been used. How many play both sports? So method 1, let's just kind of do it intuitively. So let's do our 2 circles overlapping, because we're going to see how many play both sports. Through our Venn diagram, don't forget to label it U. And we've got rugby and soccer. So soccer, maybe I'll give an S, and rugby will give an R as our label. So we don't know how many play both sports, but we can potentially work that out. The really key important information here is that 3 play neither sport. So you know for sure, the only one you know for sure that you can put down is the number 3. Because you know there's 42 in total, and 25 play soccer. So 25 refers to this whole circle here. So 25 in total play soccer, and 27 in total play rugby. So we don't know how many are in the intersect at this point. But you can work out what the union must be. So the union, remember, which is both circles added together. So union must equal the total minus the neither part, the part that's on the outside here. So the total minus 3 means that there's 39 students in total in the union. So by the union, remembering that the union refers to everything inside both circles. So we know that the union should add up to 39 students. But if you add up the total soccer and total rugby, if you add those together, you don't get 39 students, you get 52 students. So the intersect must be the difference between this and what it should end up being. So the intersect, it'd be worth writing this down so you've got this to look back on. So the intersect must contain the difference between these two numbers. 52 minus the 39. So the intersect must contain, if you do think what's 52 minus 39, it's 13 students. So now we know what the intersect is. We know the intersect is 13. So we've actually answered the question already. How many play both sports? It's 13 students. But out of interest, let's just work out what the rest of the Venn diagram would include. So let's do only soccer. Let's see. So maybe let's now do here. Only soccer must be the total soccer. Total soccer is 25 minus the intersect. So 25 minus the intersect will give you 12 students. So there must be 12 that play only soccer, because 12 plus 13 equals 25, and 25 in total play only soccer. Now let's work out only rugby, or rugby only. There's 27, according to the top of the question, that in total that play rugby. 27 minus 13 will give you how many play rugby only. So there's 14 here that play rugby only. There is a second method. In the textbook they outline a second method, which I'll also describe to you. So that's kind of using algebra instead. So we'll just section off this bit here. So if you're using algebra, the way they kind of do it is they say, let x equal the number who play both sports. So let's say let x equal the number who play both sports. And then once you've defined that, you can start to write the Venn diagram. So let's just set up our overlapping circles like before. Let's put a U here. And again, let's label it soccer, rugby. So let's say x is what plays, how many play both sports. So let's label the intersect with x, because that's how many play both sports. In terms of soccer, and we know, of course, as like before, there's 3 here. So 3 on the outside, we know that's a definite, so let's put that in there. We know that there's 25 in total that play soccer. So soccer only must be 25 minus the intersect. So 25 minus x. And over on the right, we know there's 27 that play rugby in total. So how many play rugby only? It must be similarly 27 minus x that play rugby only. And we know that all of these expressions must add up to the total, which in the top of the question they say is 42 girls. So let's write it all out. So let's make these, add these all together. 25 minus x plus x in the middle plus 27 minus x. Don't forget the 3, it's easy to forget the 3. Plus 3 equals the total, which is 42 girls according to the question. And then we can just collect like terms. What's 25 plus 27 plus 3, basically? It's like saying 25 plus 30, because 27 plus 3 is 30. 25 plus 30 would give you 55. And then thinks what's negative x plus x? That cancels to 0. Subtract x, overall is minus x, equals 42. And there's different ways you can solve this. We're just now going to find out what x is. So if you could go negative x equals 42 minus 55, that works fine. You might also prefer to go 55 equals 42 plus x. That can make the x positive to begin with. That's also okay. So x equals 55 minus 42. So we subtract the 42 over. So x is equal to 13 students in total. So what's important is to actually make sure you've kind of defined that the final answer is 13 students. That's perhaps what I didn't do in the method 1 example. I probably should state that a bit more clearly. So just make sure 13 students play both is clearly your answer. And maybe feel free to circle it or something like that. Just make it clear that you've got your final answer is 13 students play both. Because that's what the question was asking for. So 13 students play both is all they were asking. How many in total play both? So that's two methods. I tend to prefer the top method. Top method works fine if you've only got 2 circles. When you get 3 circles, that's when the bottom method is definitely a goer. So feel free to write out both and maybe practice a bit of both as well, so you're good at both methods. Because, for example, in this one, I find defining what you're looking for as X will be way easier because you've got 3 things to look at now. It's way more complicated. So you've got a class in total of 160 students. So that's important, that's your total, might be worth noting. Each one was asked to choose 1 or more science subjects. So to choose 1 or more, this means that there will be no students on the outside. So no students on outside of the circles. So no students on the outsides of the circles is what that's referring to. That's important to know, that there's no students who chose none of them. So they're asked to choose 1 or more science subject from biology, physics and chemistry, and who were told 68 in total chose chem, so that's the whole circle, 68. 65 chose physics, so the whole circle for physics should add to 65, and 47 chose bio, so the whole circle for bio should add to 47. Now there's a bit about intersects. So we're told 11 students in total chose biology and physics, so that's referring to that whole part there, the whole incision part there. For example, these kind of things. You'll see when I draw them on the Venn diagram, it'll be better. So 11 students chose both bio and physics, 9 chose both physics and chem, and 15 chose both chem and bio. How many students chose all 3 subjects? So they want to know the intersect of all of them. So thinking basically they want to know what's the intersect of biology, physics, and chemistry. Just practicing writing out our notation as well. So this is one where it's much easier if you kind of set it up with X. So let's say let X equal the number of students who chose all 3 subjects. So basically the intersect of all of them. Subjects. So that's a good thing to define to begin with. And now you want to kind of set up your Venn diagrams. So you've kind of got 3 overlapping circles, because we know we're trying to find X, which is that part right in the center right there. Oops. Let's try that in again. Don't forget your outside box. Some people do forget that. If you want to, you can just remind yourself that the outside's got 0. That's okay. You can do it if you like. You can do it in green. But you don't have to put 0 or the null set. So that's just maybe this, just so you don't forget that there's nothing on the outside. We know that X is in the center. That's how many we're trying to find out. Chose all 3 subjects. We also need to label our circles. I'll do bio here, physics here, and chemistry here. Just randomly choosing to do it that way. So now you again work from the center outwards. So work from center outwards is a good idea here. Work from center outwards. So by outwards I mean like kind of go into these parts here now. So we're going to kind of start to fill in these ones. And the information that helps us to do that is not the total circle bit, but the bits where they say just 2 subjects together. So we know 11 chose bio and physics together. So 11 chose bio and physics. So as bio and physics, it's here. So this whole section here must add up to 11. But we don't know what X is. So all we can do at this point is define this part here as 11 minus X. Because that whole section here, as we said, must add up to 11. So this little section out here must be 11 minus X. So let's write that one back in there, 11 minus X. Another one we can do. So we know 9 chose physics and chem. So let's look at the physics and chem section. This whole section must add up to 9. So the little outsidey part here must therefore be 9 minus x. Now let's do this other little last one here. 15 chose chem and bio. So chem and bio is over here. So this whole crescent adds up to 15. So this little outside part here must be, it's pretty hard to write it small with these pens, 15 minus x. Now we can kind of start to come up with something maybe for only physics, for example. Only physics, what's this thing out here? So to do that, it's pretty tricky. You're going to have to come up with a big, messy equation. So we know total physics. Total physics, where did they talk about that? Let's have a look up in the question. 65 chose physics, just here. 65 chose physics. So we've got the circle for physics. So this whole circle adds up to 65. So let's try to use that to come up with an expression for that little part there in terms of x. So let's write out all the stuff we've got. And maybe let's also label what we're doing too. Only physics equals this one here. So only physics, we've got 11, we know there's 65 in total. So let's go 65 minus to begin with. 65 minus 11 minus x. These brackets are really important because you're going to have minus 11 and then plus x because of the brackets. And don't forget it's also minus the blue x in the center. And in the physics circle, we've also got the purple 9 minus x. So again, use brackets for that. So 9 minus x. And then maybe do your expanding. So equals 65 minus 11, but don't forget you're doing this. Minus 11, negative x is plus x. And then the blue minus x is still there. Then negative 9 plus x. That's really important you do these kind of like expanding carefully. And then when you work out what this is, 65 minus 11 minus 9, it's like saying 65 minus 20 really, isn't it? So that becomes 45, and then plus x minus x cancels out, so you've just got plus x at the end here. So 45 plus x is what goes right here. 45 plus x. Underline it there, just to point out where that came from. So then when you look back at your notes, you can see where that number comes from. It's good to colour code a bit. Now I'm going to choose to do only bio next. We're going to do it for all three, come up with a little expression. So you can see this is a lot of work, but it pays off. So only biology, look back at the question. How many in total study biology? Let's see. 47 chose biology, is what they say halfway down. So 47 in total for bio. So the whole circle, we can work out what this little part here is by going 47 minus, let's see, the 11 minus x is part of the bio. So 11 minus x is part of the bio circle. Then we're subtracting off the blue x, because that's also part of the bio circle. And then we're subtracting off the red 15 minus x. So that's the other part of the bio circle. Now let's simplify that expression, or actually let's just deal with the expanding first. 47 minus 11, but then it's plus x. And then there's a blue minus x still. Minus 15 when we expand, and minus x plus x. And that simplifies to, let's see, 47 minus 11 minus 15 is basically like saying 47 minus 36, which gives you 21. And again, you've got plus x, minus x, plus x, which simplifies to plus x. And maybe let's underline this in a different colour. Let's put this nice green under here. 21 plus x. So we'll write that up here. 21 plus x is an expression to represent how many are bio only. Last one we've got to do is now chemistry only. So let's see, only chemistry. That's how we'll label this part. You can see this is a lot of work, and it's meant to be a lot of work. This is meant to be a difficult question. So only chemistry. Look up at the question, how many study chemistry in total? So 68 chose chemistry. So we've got to start with 68 equals, sorry, 68 minus. So the part that is just chemistry here is 68 minus. So we've got the 15 minus x in red. We're subtracting off that section. We're also subtracting off the blue x in the centre. We're always subtracting off that because it's always in the middle of all three. And then 9 minus x in the purple bracket. Next step, do your expanding. 68 minus 15 plus x minus the blue x minus 9 plus x. Now let's combine the expressions. Equals, so let's see, 68 minus 15 minus 9 is like saying 68 minus 24, which takes you down to 44. And then plus x minus x plus x just becomes plus x. Maybe let's underline this in a nice seminy colour. 44 plus x is the expression that goes in here. This is chemistry only. 44 plus x. So we haven't finished yet because we're still trying to work out what this blue x in the middle equals. But we're remembering also that there's none on the outside because the question said every student had to choose one or more. So no students chose neither. And we know there's 160 in total according to this part here. So we can now, all of these expressions here, 1, 2, 3, 4, 5, 6, 7, 7 expressions we can add together and set it equal to 160, and we're going to solve for x. And if you run out of space on your page to do this, maybe just do it up the side here. Like that's what I do on my handwritten notes. Just wrote along the side. I'll do it down the bottom though. It's difficult for you to see if I write sideways in the video. Okay, it's kind of hard to see it all. So I'll try to just sort of zoom down to there. Okay, so 21 plus x. So let's write all the expressions out. I'll do it down here. 21 plus x, and then plus 11 minus x. When you're adding, you don't really need to use brackets because when you're adding, the signs won't change. It's when you're subtracting that the brackets are important. Plus 45 plus x. That's a yellow bit here if you're wondering where that came from. Plus the purple 9 minus x. Plus the blue x in the middle. Plus the 15 plus x. Plus 15 plus x. Don't forget the 44 plus x down the bottom. Plus 44 plus x equals 160. Just check, did you get all expressions? There should be 1, 2, 3, 4, 5, 6, 7 expressions. 1, 2, 3, 4, 5, 6, 7. Got my 7 expressions. Now we've just got to combine like terms and solve for x. So let's see, 21 plus 11 is 32. 32 plus 45 and so on, plus 9, plus 15, plus 44. You should hopefully end up getting, let's see, you end up getting 145. Feel free to check that if you like. Because let's see, 44 plus 15, let's see, that's 59. 59 plus 9 is 68. 68 plus 45 is 113. 113 plus 11 is 124. 124 plus 21 is 145. That's kind of how you can do it in your head. Now let's work out the x's. X minus x cancels out. Plus x minus x also cancels out. And also, notice I did a boo-boo here. See where I've written, let's see, what have I done? 15 plus x. In the bottom, I should have 15 minus x, so let's fix that. So 15 minus x. This doesn't change our number, because it's still plus 15, but it's going to change our x's. So then it's plus x minus x cancels out again, plus x. So 145 plus x equals 160. And now we just solve for x. So x equals 160 minus 145. So x equals 15 students. So 15 students in total selected all three. Always just double check. Is the question asking how many chose all three? And yes, it is. They just want to know what x is. So 15 students chose all three. So that was a lot of work for one big question. So as you get towards the end of the exercises, you'll tend to find sort of questions like this. A lot of the questions at the beginning are just for double circles, but this is an example of a harder one with triple circles. Let's move on to another one. Okay, this is a pretty tricky one as well. We've got 3 circles. And I've also got work solutions for this one on the back, but I thought I'll also just show it to you how you would work it out via a video footage. So 24 dogs are in a kennel. 12 of the dogs are black. So it's also good to just say 24 dogs in total. 24 in the total. So 12 of the dogs have black fur. So that's useful. Sometimes it helps to write the numbers. 6 of the dogs have short tails, and 15 have long hair. There's only one dog, you might miss this, so maybe put the number there. Only one dog that's black with short tail and long hair. 2 of the dogs are black with short tails and do not have long hair. 2 of the dogs have short tails and long hair but are not black. If all of the dogs in the kennel have at least one of the mentioned characteristics, meaning that no dogs are outside the 3 circles, so there's no dogs outside the 3 circles, so the outside is 0. How many dogs are black with long hair but do not have short tails? Okay, that's pretty tricky. So I've kind of filled in the Venn diagram a little bit. I've actually drawn the circles for you. So I've said let x equal what you're actually trying to find. So it says how many dogs are black with long hair but do not have short tails. So let x equal the number of dogs which are black with long hair and do not have short tails. Sorry, just one second, I'll pause and start this again. Here we are back again. So it said again, remember how many dogs are black with long hair but do not have short tails. So let x equal the number of dogs that are black with long hair but do not have short tails. It's always good to make it equal what you're actually looking for. Alright, so let's label let B for black fur, S for short tails, and L for long hair. We don't, let's see, there is one dog that is black with short hair and a long tail. So that's useful. There is only one dog that's black with short tail and long hair, sorry. So that means that the center is equal to 1. So it's always good if you can work from the center outwards. For this one, x, let x equal the number of dogs that are black with short hair and have long tails. So black with short hair and do not have, long tails is this little section here, isn't it? Would you agree? So it's a mixture of black, black with long hair, and do not have short tails. So not part of the short tail circle, but still part of the black and long hair, so it can't be part of the center. Okay, so 0 on the outside. Sometimes you should just write it in just so you realize, okay, you might forget after doing all this work there's meant to be nothing on the outside. What else can we do? Let's look at some of the combos. 2 of the dogs are black with short tails but do not have long hair. So black with short tails but do not have long hair would be right here. So black with short tails and do not have long hair. That might be worth putting out a little note, just so you look back on it and you realise where that came from. So I'm just going to undo that there. So I don't want that there. Another thing is 2 of the dogs have short tails and long hair but are not black. Short tails and long hair but are not black would be right here. That's because it's short tails, long hair, and it's not part of the black circle. So at this point we now need to come up with some expressions using x. Let's see how many dogs are meant to have black fur in total. 12 dogs, according to the question. Up here, 12 dogs are black in total. So we can come up with an expression for the part here, which is for black fur only. So let's say that here. We know that total circle for black fur should add up to 12. So black fur only must be equal to 12, which is what the total circle adds up to, minus green 2, minus the blue 1 in the center, and minus the green x. So let's see, when you combine like terms, what do you get? 12 minus 2 is 10, 10 minus 1 is 9, so 9 minus x is your little expression. So that can go in here. 9 minus x, let's underline that right now. Now let's work out this part here, which is short hair only. So let's do that down here. Short hair only. So you need to look up at the top of the question again. How many in total need to have short, sorry, I keep saying short hair, short tails, sorry. There's 6, according to the question, that have short tails. So 6 minus, I should change that to tails as well. Short tails only. Short tails only. Let's looking at the S circle. That. So short tails at 6 minus the green 2 minus the blue 1 and minus the other green 2. So we can actually work this out as a number. So 6 minus 2 minus 1 minus 2 just becomes the number 1. So the number 1 goes right here. And last one to work out is long hair only. So let's see how many in total have long hair. Let's see. 15 of the dogs have long hair. So the whole circle must add up to 15. Because it doesn't say long hair only, so it means the whole circle adds up to 15. So we're going to work out long hair only by doing 15 minus what else is in the long hair. So 15 minus 2 minus the blue 1 in the center and minus the x. So 15 minus 2 minus 1, you probably realize already, gives you 12, and then there's minus x. Let's maybe make that a nice salmon bar. So 12 minus x goes down here. You don't need to underline them, I'm just trying to color code, and I don't have that many nice colors to write with that come up well on video. And we know from the question that the total number of dogs in the kennel is 24. So again, we're going to make all of these expressions from the Venn diagrams add up to 24. So I've got 1, 2, 3, 4, 5, 6, 7 things to add together and set equal to 24. So I just need to scroll down a bit. Here we go. So the total, we've got 9 minus x. 9 minus x. So I'm that, colour code it still. Plus 2. Let's see, plus 1 from the short tails only, plus the other 2, the other green 2, plus the blue 1 in the center, plus the green x, and plus the 12 minus x as well. So the 12 minus x. And we know that that's equal to 24 because the total dogs is equal to 24. Hopefully we've got space to do this. If you don't, again, just write it up the side. When you add all the numbers together, 9 plus 2 plus 1 is 12, plus 2 plus 1 is 13, plus 12, sorry, actually, I think I've added that up wrong. 9 plus 1 plus 2 is 12, 12 plus 2 plus 1 is 15, and 15 plus 12 is 27. Now carefully add your x's. Negative x plus x cancels out, and then you've still got the minus x here. So minus x equals 24. Now to solve for x, you could subtract 27 from 24 and then divide off negative 1. Just to show you something different, I'll do that. Whereas on the other example, I added the x to the 24 and then subtracted off 24. So negative x equals 24 minus 27. So negative x equals negative 3. And then to finish off, x must, if you want to think of that as negative 1, x equals negative 3. Negative 3 divided by negative 1, so x equals 3. It's just showing you the other way. So 3 dogs in total have, let's see, 3 dogs in total. They have black hair and long hair, and they don't have short tails. So that's what we're looking for. So 3 dogs in total. So make sure to just make it clear which part is your answer. So there's no more calculating we have to do for that. On the last page, I've kind of got some a worked example of that kind of thing, just kind of trying to explain it in words as well. But it's good to have the video as well as a backup. And that's pretty much the end of this quite tricky problem solving video. So hopefully it was of some help.